So I want to show you another video which utilises the parabolic curve that you've seen in the previous two videos, but this time I actually want to make a double biquad parabolic curve antenna. Now a double biquad normally yields about 14.5 dBi when constructed correctly, so I'm hoping that we can get a little bit more out of a double biquad by incorporating it with a active parabolic curve. Now this idea is something that I actually came up with a long time ago now when I was at university, and I came up with this prototype. So this prototype is probably around 15-16 years old now, and although this prototype did work as a double biquad, the parabolic curve that you see in this is just too narrow. The actual focal point is over here somewhere, because it's actually based on a windsurfer design. So as a parabolic reflector for the double biquad that's inside there, it never actually worked, and I did move on to something else. I think I actually moved on to a helical antenna for the actual project that I had to do at the time. But I have kept this because it does work quite well, but I haven't used it in such a long time. And as you can see there, it's actually made with a BNC connector, which were as cheap as chips back then, so we used to use them for our prototypes. But people who've commented on previous videos are quite correct. The BNC is not rated for microwave frequencies, but for antennas in general, you can normally get away with them. So I've measured off a rectangle of the mesh, and it measures 200mm long and 100mm wide, and that should be just enough to fit a double biquad along its middle here. And I'm using the perspex for the spaces this time and not cork. If you've seen in my previous videos, I've actually used mesh and epoxied the cork spacers directly to the back of the mesh, but because this antenna is going to be slightly longer, I'm going to use the perspex ones. Now as I'm using screws and epoxy, the mesh is flexible enough that I could bend it round and mark out the holes and then put the screws in, but I am going to put a slight curve in this just to make it a little bit easier to actually handle and mark out the positions where I'm going to actually screw into the perspex itself. So the same method as before, but it doesn't take as much force to get that bend actually into it. So I'm now going to measure off the positions where I'm going to place the spacers. Now the measurements that I'm going to use, as you'll see later on in the video, they're not just random measurements. I've chosen them for a reason, but for now I'm going to measure off this spacer first, and it wants to be 75mm in from this outer edge here. So if you've got a ruler like I have, 75mm, and butt your spacer up to the end of the ruler, that's where the first one wants to be positioned. And I've put a piece of masking tape down the middle so I know where the centre is, but you can actually line up this spacer here along the mesh here, so you can actually line it up nice and straight using the mesh as a guide as well. The next spacer wants to be positioned 30mm in from the edge of the reflector, butted up to the beginning of my ruler, as you can see here. So I'm going to fasten this one down with some masking tape next. So those two are positioned where I actually want them, so now I'm going to flip it round and do the exact same thing on the other side. So all four spacers are in place now, and they're all nice and uniform. I've double checked my measurements. If you've got one a little bit skew with, you can also just peel back the masking tape and just reposition it. That's the beauty of actually using masking tape. So now if we flip it over, I'm going to actually cut away some of the masking tape from the back here so I can see the underside of those spacers, and I'm going to drill the pilot holes now to hold them permanently in place. Now because I'm using mesh for the reflector on this antenna, it's a lot easier to actually measure out for the pilot holes for the actual spacers there to put the little screws in. Now if you're going to use a solid piece of tin, you're going to have to do the method that I used in the previous video. I'll link the previous video in the description down below in case you haven't watched it, but basically you're going to have to mark off all your screw holes prior to actually bending the curve into your parabolic reflector there. But because I've got this mesh, I can actually use the holes in the mesh to actually guide me where I'm going to put my screw holes. Now I've got a piece of masking tape running down the middle of the reflector here, and I've put a blue line exactly where the middle is, so I can see that through the actual masking tape, so I know that my middle screw is going to go in there, so I'm going to drill the pilot hole directly through the gap in the mesh there. And the other two pilot holes that I'm going to actually drill, I'm going to measure 15mm in from each side, and I'm going to choose the appropriate hole in the mesh to actually put my pilot hole in. So for the edge here, I'm going to actually put my pilot hole in the gap in the mesh just there, so the mesh is making it a lot easier to actually mark out where the pilot holes for the screws are going to be. And instead of just marking them off with a permanent marker like I did in the previous video, I'm just going to drill straight through the hole in the mesh there, and drill it straight away and put these screws in as I'm going along. So it's working out pretty well using the gaps in the mesh here as a guide to where I'm going to put the pilot holes for the screws. And the screws, again, I'm just using the same ones in the previous video, just a rounded head Phillips of about 5mm, well they are 5mm long, but again, when you're actually drilling your pilot holes for your screws, the two outer ones, just try and hold your drill at a slight angle so the head of that Phillips actually sits flush on top of the mesh and not crooked if you would drill straight down like that, so just at a slight angle to that parabolic curve. So the reflector itself is finished now, all the screws are in place, so what I'm going to do now is put this to one side and move on to the double biquad. So to make the double biquad, what I've got here is my little measuring tool, and I keep it on a keyring with some other measuring tools that I have. And basically what I've got here is along here in the shortest, it's 31.25mm, and here along its longest section it is 62.5mm. so this is my little measuring tool that I'm going to use to construct the biquad. It's just a lot easier using something like this than measuring off each individual measurement with a ruler. It's also a lot more efficient, and you get each measurement then, each bend really spot on with using a tool like this, but using a ruler for each measurement you can end up making errors. And of course you can make a little tool like this as a one-off using some thin plywood or a piece of metal, something hard that's not going to bend too much. And the pliers that I'm going to use to put all the bends in are these ones here. Now I like these ones, these are my favourite ones because I've got this flat surface here that I can use to butt up my measuring tool to actually get the bends in there at the correct wavelength. Now the wire that I'm going to be using is this steel galvanized wire. I'm not using copper wire because the element is exposed, and copper wire is a little bit too soft. This is a lot stronger and it'll hold its shape better. Plus, making a biquad out of this and out of copper wire, there's no difference whatsoever really. So the way I do this, what I do is I just estimate a length, and I actually want the length on here to be 15mm or a little bit longer, so I just guesstimate my first bend like so, and I have just estimated this to be greater than 15mm because I want the elements of the antenna itself to be 15mm away from the back reflector. So just make sure you've got more than 15mm so you can actually play and measure it correctly later on. If it's a little bit shorter, then you're going to have to either mess around extending it or make another antenna. So I'm now ready to put my first measurement in there, so I get my measuring tool and I butt it up against that first bend that I did there, and then what I do, I get my needle nose pliers, and you can see now how that flat surface on there really helps me, and I put my first bend in and I bend it like that. So I'm now going to do the next measurement, which is a long measurement, but I've put a little piece of heat shrink tubing on there because this antenna is going to crisscross over itself, and I don't want it to short itself out. So a little bit of heat shrink tubing in there before I put the next bend in. So this one is a long bend, again buttered up to the edge of that last bend that I put in. And I'm actually going to bend it towards me this time. So we've now got it looking like that. So now I'm going to put another shorter bend in. So next it's another short bend, and bending that towards myself again. So now you can see where it's actually going to crisscross over the element itself, but we're going to put another short bend in here. So I'm now going to put a bend back in on itself again. And as you can see, we're starting to get that bow tie effect now. Don't worry too much about getting them all straight at this stage. You can actually go in and straighten them all up to get them as square as you possibly can when you get the full antenna constructed. So the next bend is another short bend. And I'm going to bend it away from itself again. So next it's another long measurement. And this time we're going to bend it this way back in on itself. So short measurement now, bending it in to bring it back in on itself and cross over there. So remember, when you get to this stage where it crosses underneath, to put some heat shrink tube in before you put another bend in here. So it's another long bend back in on itself, and then finally a short bend, and I'm going to be bringing it down to match up to where I actually started. So now what I can go ahead and do is chop away any excess that I don't actually want, and then really get the right angles on this antenna and tidy it up a little bit. So I've cut away one of these legs, the part that I don't actually want, because I only want one of these legs to actually go down and make contact with the reflector itself. But because this wire is slightly thicker than what I would normally use, it's 2mm diameter, I've got the Dremel tool and just ground away to make a little joint there, so I've got much more of a flat surface to actually solder to, because I'm going to solder these two parts of the element together to join that loop up. And you may find actually soldering these two together a little bit tricky, because you'll get them positioned, and then when you go in with the soldering iron, when you heat up the metal, because it expands, it'll pop apart. So if you hold them together in a vise, then you can really get in there with the heat of the soldering iron and do a really good job of soldering those two together. So now that I've actually finished the element, you can see why I chose the measurements for these supports, the actual placement on the reflector itself, because if you use the same measurements as I did, then all the top corners of the biquad element make contact with the supports themselves, and I'm going to epoxy the element in place, so it'll be a lot more sturdier that way, and it also looks much neater. Now, to actually connect to this antenna, what I'm going to do differently, I was going to use a bulkhead connector, but I'm going to directly solder on a piece of coax, and what I'm going to do, I'm going to solder onto the back reflector here, and then have the signal wire going up and connecting to the biquad. But rather than just soldering directly onto the reflector itself with the coax, which it won't last very long, it's like a little weak point there, and it'll end up snapping and coming away. I'm going to use a small piece of tubing here. I'm going to widen one of the gaps at the centre here in the reflector itself, and I'm going to solder on a length of this tubing, probably about 15mm, and feed the coax through there and solder the outer braid directly to the tubing itself, and having the signal wire coming up and through, and that can go and then connect onto the biquad antenna. I've soldered the piece of tubing in place, as you can see, and I've soldered it on both sides, so it's in there, it's nice and strong. Now what I'm actually going to do now is the outer braid here, I've cut most of it away, but I've left a small amount here, and I'm going to pack it down into the tube, and then I'm going to flow solder into the tube, and the solder will stick to the inside of the tube and the outer braid, and we'll get a nice strong fixing there for the coax itself. So the tube will add some strain relief, and with all that solder mixed in with the actual outer braid as well, soldered onto the inside of the tube, it'll be a really strong connection, much stronger than soldering directly onto the back of the mesh itself. So I've got the coax soldered up to the tube now, and I've also cut back the signal wire and pre-tinned that as well, ready to actually solder onto the biquad. And to tidy this up a little bit, you can just put a little bit of heat shrink tubing around there. So I'm now getting ready to mount the element itself. Now what I've actually done, I've got the PVC pipe here that I use to roll out the parabola, the back reflector, but I've just got my biquad and laid it on top, and I've just pinched in each of the corners slightly just to give it a slight curve, just so it's going to be a lot easier to mount onto these plastic spacers here. So the antenna is finished now, it just needs a coat of paint. I epoxied the element onto these spacers here, and I think if I was going to do this antenna again, I would cut little trenches in there for it to sit a little bit neater, and I think it would actually hold it a little bit better. I don't think that epoxy like this is going to do a long-term job of actually holding the element in place. And something else I've also done, I've put a little bracket on here so I can actually attach a small tripod to it. Now what I've used for that is I've got quite a few of these little right angled fixings that I got off eBay. They're pretty cheap, and I've just done this with the biquad Yagis. I actually tapped out, threaded out one end, and I've also bent it a little bit more so it's not quite at a right angle for this antenna, and riveted it in place onto the reflector itself, and it does quite a good job of a tripod attachment. So all that's left to do now is to give it a coat of paint and a test. Now what I'm actually going to do, I'm going to test it against this one that I made all those years ago at university, and we'll see how well it performs, because remember I did make a mistake with this one. It's not a true parabola as such, because the focal point is so far in front. It's not where the actual element on this antenna actually is. So I've got the original one that I made all those years ago at university, and I'm just trying to move it around a bit, because remember both these antennas are directional. And I've also got the test router a little bit further away. It's about 60 meters away this time, going through 4 brick walls, just because I know how powerful a double biquad really is. So it's not too bad. It's what I would expect from a double biquad. So what I'll do now, I'll disconnect this and put the new version of the double biquad with the parabolic curve on. So straight away there's a big jump there, and remember there's no difference between these two antennas. They're both double biquad, but this one has a parabolic curve where the elements are actually bang on where the parabolic curve focuses. So you can see there, much better signal and more dB. So I'm pretty pleased how this antenna's turned out. Normally I build quite a few prototypes and what have you, try and air out any problems with the design before actually filming a antenna build, but this one I've just done this on the fly, so this is actually the only one that I have got, and you know, I'm pretty pleased how it actually turned out. It was prompted by me finding this in a box, and it reminded me all those years ago. So as you can see from the size difference, you'd expect this to probably perform a lot better than this, but because the parabolic curve, the focus is too far in front from the elements, it doesn't benefit from the extra dB that a parabolic curve can give you. So again, I hope you enjoyed that video and you found it interesting and informative, and if you did, please give it a thumbs up and drop a comment below, and hopefully you'll join me on the next one.